Okay, so the empirical rule is really good if you've got a nice number of standard deviations away. If it's 1 standard deviation or 2 standard deviations or 3 standard deviations, if that value is a whole number of standard deviations or a negative whole, negative 1, negative 2, down 2, down 3, but that won't always happen. You won't be a nice number of standard deviations away. So the empirical rule has its limitations, but it is helpful in some instances because you don't need a table. If you're not a nice number of standard deviations away, yeah, you've got a table. So let's look at the table. We're just going to look at it out of the book here. For this book here, let's see, we're on table 16, I believe. If I find it.
690.
690. Yeah, covers the whole page. So on page 690, that table, table 16 for this particular book. Let's look at that for just a second. All right. So if you look at that table there, just look at the first, the left side of it here. Yeah, we've got our nice bell-shaped curve. All right, and here's, first of all, so again, kind of what we were doing with the empirical rule, right? But we're finding what the table gives me is the table gives me this percentage right here. Now, let's notice a couple of things. First of all, all right, first of all, notice this, you got a Z there. What do you know about Z? Z-score? The table is based upon Z-scores. Okay, so when we have a value, the first thing we're going to, or values, the first thing we're going to do is calculate the Z-score. The table is based on Z-scores, and so we're going to use that Z-score formula. Remember, Z is equal to the value minus the mean divided by the standard deviation. So that's the first thing. All right, now, when we go over here, oh, and then the other, all right, so I thought the mean was in the middle. Why is 0 here? Well, if you do the z-score of the mean minus mean, that's 0, yeah. That's still the mean, it's just that the z-score of the mean is 0. Okay, so don't let that throw you off there. All right, so what the table gives me is the percentage between the mean and the value. That's what the table gives me. So it's the percentage between the mean and the value. That's important to understand. All right, so when I go over here, I've got Z and then A. Let's just skip on the first row there. Let's skip down. So I've got, let's go down to Z is 0.13. The A is 0.52. So what that's telling me is if my z-score is 0.13, this A, so this is A right here, that's what they're calling A. That A is 0.052, or in other words, 5.2%. Because that's, we normally deal in percentages, okay? So yeah, the other columns have bigger z-scores. So the second column has ones. Like down here, you have z-score of 1.60. It has 0.445 is A, 44.5%. Okay. So what we're going to do, we've got our values. We're going to get the z-score. Look at the table. And that's going to give us our percentage, and this the percentage between the mean and that value. Okay. So understanding.
I have a question.
Table. Question.
Can you tell me what you wrote above Z equals? No, the Z equals what?
Value minus mean
Okay, thank you.
divided by standard deviation. Did that one yesterday. Okay, so with that in mind, let's do these. All right, so let's say the average length of fish caught at a lake is normally distributed with mean (12) and standard deviation 4.1. Okay? So let's use the table to find the following. Number one, find the percentage of fish caught between let's do 10 and 15. No, let's do 10 and 17. Find the percentage of fish caught between 10 and 17. So this time we're going to use the table because notice 10 is not a nice number of standard deviations from the mean. One standard deviation is 4.1, so if you go one standard deviation for one thing, that's not going to give us nice numbers anyway, no matter what we. So yeah, we can't use the empirical rule is the point I'm making there. But it is still, draw the picture. 12 is the mean. 10, where is it? Well, that would be below the mean. 10 here. 17 is above the mean, okay? So I want that percentage between those two. But I have to use the table. And the table is based off of z-scores. So what I'm going to do, first of all, is just calculate the z-scores of each. Z-score of 10, z-score of 17. Let's do 17 first. Because I got to make a point. How to do the z-score? Value minus mean. So it would be 17 minus mean is 12 divided by 4.1. That's 5 divided by 4.1. Which is, and notice the z-scores are in two decimal places. So I'm going to say 1.22. 2 places, because that's what the table has. Okay? All right, so I go to my table and I look up the A. Well, the A there for 1.22, remember you look to the right to get the A. 1.22 is 0.389,
Yes.
which is 38.9%. Okay? All right. Now, z-score of 10. Well, the thing about that is I get 10 minus 17 divided by 4.1. That's a negative 7 divided by, oh, I'm sorry. That's right. 12 is the mean. So 10 minus 12 is negative 2 divided by 4.1, which is negative 0. About a half. 0.49. If I do 2 places, round off to the nearest second place there. With me? Now, do you see a negative z-score on that table? No. There are not negative z-scores on the table. However, by symmetry, the negative z-scores are going to have the same areas as the positive z-scores. So just look at positive 0.49. Okay? Because it's by symmetry the same. So what do you get? What's the A there? A is Z is 0.49 towards the bottom of the lower left. 188. 188. Everybody there? Got it? So that's 18.8%. Now, looking at the, here's where you kind of remember, we've got the less than, more than thing. If the values are on, one's on one side, one's on the other side, remember what we did there? What did we do to these percentages? We added them, didn't we? Because what this, and you can see that because what we found is this is 38.9%. This then is 18.8%. Yeah, so I'm just going to add those two together. Was that 9? So that's going to be, what, 50, 56, 57.7?
Yeah.
Okay. If they're on the same side, you subtract. Yeah. That's the rule of thumb there. If the values are on the same side, you subtract. Same side of mean, subtract. If one's on the left of the mean, one's on the right of the mean, they're on opposite sides, in other words, you add. That's the kind of the general rule there. Okay. Just to give you a count out of there. All right. So let me do one more, and I'll be done. So number 2. What percent are longer than 18 inches? What percentage are longer than 18 inches? Okay, so we got mean is 12. 18 is here to the right. I want to know the percentage that's longer than that. So it'd be this little piece out here. But again, I'm using the table here. So what do I need? First of all, after the picture, draw a picture, do the z-score, right? Z-score of 18. So we do value minus mean divided by standard deviation, 6 divided by 4.1, which is 1 point something. 1.46. Go to the table, get the A. What A goes with Z is 1.46. Well, I see 4.428, or 42.8%. Well, our little note up there says, yeah, if you've got less than or greater than or more than, longer than, you're either going to add to or subtract from 50. What is the case here? Subtract or add to 50? Well, it's not add to 50, is it? Because the 50% here comes from that, right? That's 50. So what is that? 50 minus 42.8. Yeah. In this case, you subtract 50, because to get that piece, you got 50 is less than 12, so that's going to be 50 minus 42.8. Okay? Question? 7.2%.